Welcome to the HiRSE Seminar Series on Research Software Engineering in Helmholtz and beyond.
It's a pleasure to welcome everyone, and I thank the people behind the HiRSE Seminar Series for this opportunity to speak about the teachingRSE project. Thank you all for your time of being here. My name is Florian Goth from the University of Würzburg, and today I'm going to present you something about the teachingRSE project, what we have been doing, where we come from, what we are currently doing, and what might be in the future for a professionalization of RSE education. Okay. This also works. So what are we going to talk about? Some introduction. And after that, we will have a bit more about the education for RSEs. Then what we have so far, and we will see what are our upcoming projects, what we set our goals in the future. And towards the end, I will show you what are the opportunities that you have for joining our project, because they are right now already quite numerous. So, to set the stage, all of us knows how software development in academia usually what it looks like. It has been put into words by Greg Wilson from the Carpentries, how to get scientists to write better code. And many scientists and engineers spend much of their lives writing, debugging, and maintaining software, but only a handful have ever been taught how to do this effectively. After a couple of introductory courses, they are left to rediscover or invent the rest of programming on their own. The result, most spend far too much time wrestling with software instead of doing research, but have no idea how reliable or efficient their programs are. So what is the takeaway message from this by our standards quite old quote, but still true 20 years after? Software in development in academia is often done by ad hoc developers. And in software development in academia, long-term reliability and reusability are usually not of a primary concern. And there's also a lack of incentive to do better software development. To mitigate, where does this most of the time actually lead to? What are the manifestations of these ad hoc research processes? I mean, all of you know these things most likely. We have issues of maintainability, that no one knows how the software stack is built up, and some things might break at any time. Put into graphics famously by this famous XKCD comic. Then also another part of maintainability. Every one of us knows, maybe we don't want to look into other people's code, since it maybe is like spaghettis. But we want to have more something that is less like spaghettis, but more like tortellini, for example, something which is better packaged and has a better modularization. And the other famous things that come with it. All these ad hoc development processes might lead to security issues. Famously put to you into a headline by the Bild-Zeitung in April, when a security hole in OpenSSL SSH was discovered. That was it. These are the symptoms. Those who would actually work against that also face a lack of recognition, because even if you try to work against not optimally maintained software, if you try to make your software actually better so that other people can reuse it, if you try to fix your bugs early on time and not only when they are in the way of actual research, usually you face a lack of recognition. And that's where the RSE community comes in to mitigate these symptoms. A lot of software developing scientists, let's call it like that, in academia joined forces and formed our RSE movement to improve the situations for RSEs in academia. Most of you know the stories. The name has been coined in 2012, and lots of stuff has happened in the 10 years by now. And we actually now have a job profile for RSEs that we can search for and go, for example, to LinkedIn You can ask LinkedIn to give you job postings for research software engineers. So there are the employers by now have kind of a feeling of what a research engineer is supposed to, how it fits into their organizations, and they try to bring up job advertisements for that. But what about the other end of the pipeline? So we have job positions where these people come in. But where do you get them? Is there, it's Black Friday today. It's not yet that anybody of us has seen advertisements like that anywhere popping up, that people are trying to bring their RZs into organizations. I mean, I took a satirical approach over here. Get your RZ today. Are you tired of wasting time searching for the perfect coder? You want your very own RZ, fully trained and ready to work. Look no further. We are offering premium RZs ready to tackle all your coding needs. Why you should buy an RZ today? No more hiring hassles. Why go through endless interviews when you can buy a fully formed RZ off the shelf? Fully customizable. Choose your RZ skill set. 24/7 productivity guarantee. And able to cope with endless feature requests. Secure your RZ today. While satirical, it brings up a couple of points that would need addressing. So the organizations are looking for RSEs, but since there's not yet a coherent curriculum formed that people can ask for, if you're putting out a job ad for an RSE, you have to perform endless interviews actually to find out about an RSE that fits your description. There is not yet a RSE masters that you can ask. Okay, I have this job role to fill in my organization, and RSE masters would fit. I can look into the graduates of an RSE masters program. These things don't exist. You don't know which skill sets they bring, the people. You have to really dig into, in the job interviewing process, you have to really dig into the CVs of the persons to find out what they actually bring. And yeah, the other two items, productivity guarantee. I mean, this is not something that we can probably not fix with, we can't give guarantees with education, but we can surely improve it and make sure that the RSEs that graduate from our courses are able to improve the work environment with the unique skill set that they bring to the table. So to put this on, where do we get them now? So far, since there are no master's courses, usually they have been grown organically. RSEs, these have been researchers that have been chosen to focus on a technical role. Most of the time, this also comes with a neglect of their researcher role, which leads to the problems in the hiring process, and also with the problems in the career opportunities. Also, if you are a person that actually is able to work in this intersection between research and software development, there is a competition from industry. So these people who can work in this intersection, they don't need to stay in academia. And also, there's anecdotally evidence that using plain software developers in research has just not worked out so well for various reasons. So the most prominent being that if you want to if you want to fit into a work group or into a research work group, you need a very high level of domain knowledge to perform your tasks effectively, which usually take years of training to get to the respective of understanding in some fields. So I'm a theoretical physics. I'm thinking of RSEs that work in high energy physics, and they need to understand the fundamental laws of space and time. Not stuff that is taught in the usual computer science courses. And also, while we are at it, maybe we can rephrase some other questions. How many of these RSE would we actually need? This is a very difficult question. I bring it up, always bring it up. Don't have an answer yet. And also, maybe we would need to not only bring up our own masters to fit the job description, but also we would need to think about how much research software engineering would we need to put into domain curricula, so that also science gets more proficient in the use of digital tools. So, with that said, to basically fill the pipeline of people who can work in RSE positions, we need to talk about how do we structure the education for research software engineers. This is the task that we set ourselves to with the teachingRSE project, and I tell you a little bit of the beginnings. The teachingRSE project, it's basically has formed itself as a community workshop in Paderborn at the DRSE 23 by now 1.5 years ago. And we started this at that time with, we wanted it was a community workshop, and we asked the audience some questions. So, for example, who would benefit from research software engineering? What are essential topics, or are there categories of RSEs? And how do we reach out to users to improve their software engineering in their daily life? And the outcome of this initial workshop has been tremendous. We wanted to organize a small workshop, talking with people, and in this room, then there were roughly 60 participants. In hindsight, I had hoped I had taken a photo, but I didn't. But I guess most of you have been there, even. We got lots of feedback that has been collected at the time, and then that we tried to structure over the next week. And we quickly came to the conclusion we can't put this into a single blog post or a single publication. This has grown a little bit bigger, and we have structured it over 3 to 4 projects. 3 of them papers. One of them became a software project that I will tell you later on. And so what we started with, we wanted to actually phrase out the foundational competencies of research software engineering in a generic way, to get away from the technical specificity that that has been in there. That there were a lot of specific technologies that people told us you need to use. But we wanted to phrase this slightly more generic to stand the test of time. The next thing would be, if we have these competencies, then we need to ask the question, what would be structures and institutions suitable for RSE education? This one should have a generic interpretation, so that it can be easily copied by other national RSE societies. And also, in a similar vein, if we have the generic institutions formulated, then of course we need to formulate a call to action. So for policy changes in Germany. First, we decided to, of course, concentrate on the foundational competencies, and that we focused our work in the remainder of 2023 on. We focused on that paper in particular, and actually, around about 9 months later, it actually was possible for us to put something on the archive. The first paper, so on foundational competencies and responsibilities of a research software engineer, with a broad community of contributors. And by now, it has also been accepted as the second DERSE position paper, and currently it's, if you happen to know F1000 Research, it's available at F1000 Research, and therefore kind of published, but it's in the open peer review process. So it's published, but not peer reviewed at F1000 yet. But it has a DOI over there if you want to cite that particular paper. And in the next couple of minutes, I want to tell you a bit more of what is actually written in there, so that you don't have to go through the entirety of it yourself. So we kind of already, all of us have a kind of understanding of who software engineers are in the how to say, what they do. So these are people who create or improve research software. and the structures that the software interacts with in a computational environment of a research domain. And they are also at the same time highly skilled team members who may also choose to conduct their own research as part of their role. So a very broad spectrum is involved in there. So you have working with software, but also doing research on the other end. And now you have to face the question, which competencies do they need? And to actually, because that's what we are doing over there, then is to give them to give these graduates an identity. We started at an even lower level at the values of research software engineers. And of course, these are common values that you find at the intersection of research and engineering. So research with its commitment to openness, fact-based research, and transparency. When on the other end, the product-oriented values of an engineer, that you need to create something that is useful for humanity and society, and that can be reused by a lot of people, not only once but multiple times. So this notion brings a reliability concern into research software engineering that is less pronounced in research, I would say. And to basically, so you have to bring it into a one-sentence summary, basically, then. So rooted in a commitment to integrity, openness, and responsible use of digital tools, the RSE uses its technical, research, and team skills to contribute to the success of research projects at all levels of an organization. So you have the roots in the values, you have the skills. This is a three-pillar structure. You have technical skills, research skills, and team skills. And we expect research software engineers to contribute at all levels of an organization, not only, so there will be co-worker, there's a co-worker level is to be expected, but there's also research software leadership positions to be expected. And research software engineers should be also able to fill these positions. To elaborate on the three pillars, what is actually in there? So we have the research skills. So on a broad level, these are the skills that enable you to work in a research context and at the same time participate in it. So research software engineer can and mostly should be able to perform their own independent research if needed. So of course, these are the research software engineers that focus more on research. What the competencies that we find over there are things like a natural curiosity. It just makes it easier to work in a research environment if you have a certain curiosity. You need to know about the publication processes, so publication of papers, but also to be expected publication of software. With the ever-growing NFDI and also a lot of research infrastructure, we expect research software engineers to be able to interact with domain infrastructure at a very technical level. You should know how research works, so you should know the research cycle. Which leads over to software and technical skills. On a broad level, these are skills that enable you to create good software for your community. And obviously, in the teachingRSE project are not the first to phrase out the skills over there. The software engineering community has a large background of formulating competences that you need for proper software engineering. And we don't want to say that none of these are important. All of them are important. The skills that we picked out was people should understand the software life cycle, that software gets created, software matches, but there's also software that might be, that faces the end of its life. To put it like that, people should be able to understand software. The most critical skill, basically, to be able to do good debugging of a software program. And they should know how to create and distribute their software. Creating is everything that is behind programming, how to structure code at a lower level, but also how to write your code such that it can be used as reusable building blocks, and then also to distribute that software in an effective manner so that other people can reuse your software and build upon it. And while we are sharing your software, this brings us over to the communication skills. This pillar encompasses skills that facilitate effective interaction with either with other people outside of your team or within your team. So there's stuff in there like a teaching ability. We expect research software engineers to very often take mentoring roles, so to onboard new people. Academia has usually a high throughput of people going out of projects, people coming into projects, in integrating bachelor, master's, and PhD students. And we hope that research software engineers can play the role of onboarding new people. Project management skills can be are in there to organize software projects, but there's also end user or stakeholder interaction. So effective dealing with trouble with issue tickets, pull requests, but maybe for the leadership roles of RSEs also with stakeholders in your software project. So to secure funding, to report on funding, this is also stakeholder interactions at the other end. This three-pillar structure is what we believe the foundation of the research software engineer, of the research software engineer, but also research skills and especially communication skills. Basically, all kinds of research technical professionals might use them, but they might need them, but they bring in different technical skills. So, for example, community managers or crystal, the example here in physics, people who grow crystals for solid state physics, they need to understand the research process and they need to understand the requirements of the scientists, but they bring different technical skills. How do so this has been pretty generic on purpose, as initially stated. We want these competencies not to be stated like that for the next 2 to 3 years until the next technical revolutions comes, but the ideas behind it should stand the test of time for longer. But you need to fill them with life and elaborate a bit on what do current tasks, current everyday tasks of research software engineers look like in this framework. And so, for example, you have things like software testing. So these are manifestations of, well, understanding your program, and writing good tests for it. If you understand your program and the research behind it, it enables you to write effective tests. Maybe there are program invariants defined by physical symmetries that you can reuse to write good tests, and also to document that. So you write good documentation for a particular test. You should be, if you are effective, if you're working effectively on GitHub, for example, to contribute to larger projects. So you know how to use the respective web platform, GitHub, GitLab. You know how to find your software. You know how to write a good issue report, how to write a good pull requests. You know how to understand how to interact with other teams. These are all manifestations of the skills either in the software pillar or in the communication skill pillar. And also, as already stated, mentoring colleagues is a current day example that are within this three-pillar structure included. Of course, we also elaborated a bit on the career level in this particular paper. So, what do different people need to know at different levels of their career? So if you are a coworker in a software project, you need to have more technical skills, of course. You need to be able to actually write the useful code. But whereas if you progress to a leadership role, maybe your everyday tasks don't include so much software development anymore, but stakeholder interactions is more your daily business. We elaborated on the team structures. So whether you are a single developer, whether you are a group of single developer, or if you are, for example, for the upcoming RSE department groups, assuming there will be more of them, if you are either working on a software project within that department, or if you are basically a consultant in a research project, but you have the but you have the support of your local RSE department. And also, we asked ourselves how much digital literacy should be conveyed in standard domain courses. So, for example, if you're a bachelor in a domain, in a master in a domain, or how much should people know as a PhD student if they want to perform, if you want to use digital tools effectively into that day-to-day research. And also one other output, we started with a classification of this spectrum of research software engineers. There are people who are more, you have this three pillar structure. People can either focus on different parts of these pillars. So you have domain level RSEs, people who are proficient in a research domain. So of course they have focused more on the research pillar and less on the maybe less on the communication skills. They are open science RSEs, so they know how software development works and how research works, but they focus more on their communication skills to talk about research. Community manager RSEs, a similar pattern. RSE teachers might become important if we think about the institutions. So, of course, they have more focused on their teaching ability. HPC RSEs, for example, they are research software engineers that focus heavily on the software engineering aspect, but bring in additional knowledge about the intricacies of a particular hardware. Okay. So that is what you find in our now published publication. But more interesting maybe is what's up next. What are we currently working on in the Teaching RSE project? And currently, we are asking ourselves what are structures and education for RSE education. So we have seen that academia has proven resilient to integrate software engineering graduates directly, since a lack of domain knowledge requires a high degree of specialization. We believe that this also is present at a lower level, also in the in setting up education, and yeah, also we need to have structures that institutions that basically produce the graduates for upcoming RSE departments, so that hiring becomes more easy. That there is a pipeline coming up of a couple of RSE graduates every year, which brings up the question: how many graduates do we need each year? So that the RSE groups know where to find their graduates. So what we believe is currently, which is it's a working hypothesis. We're open for discussion that most RSEs will get their broad domain knowledge in a bachelor. So some kind of STEM bachelor with a scientific background, biology, physics, chemistry. Then they will do their bachelor in that domain, and they will afterwards attach a master where they specialize in research software engineering. And with that assumption, you can ask the question, which topics should we teach in this master's degree? This is something we will come to a couple of slides later. And also, you have to ask the question, where do you find the teachers for research, for your first research software engineering topics? Other questions that we try to answer is, which institutions should offer this master? These are questions that we are currently brainstorming. Should there be any kind of external accreditation? So that there is a slight homogenization, at least within Germany, because we need to have a kind of homogeneous research software engineer profile so that the hiring process becomes more easy. It would make sense to actually pool these teaching resources at some institutions. So that not every domain department has a new master for research software engineering attached onto their existing programs, but have it only actually once per university or even once per country. And while we are at that, we should ask the question, how do we integrate existing structure? Because there are computer science departments available at every university. How can they contribute to research software engineering courses, but also domain knowledge? How do we integrate these scientific domains? And also maybe other other places of learning. So, for example, those who teach to teachers. If we have these institutions, wherever we put them in the hierarchy of a university or a research center, then we think it is the right thing to ask them for a certain outreach into other institutions, so into the wider university, so into the domain science. So, for example, guest courses for digital literacy in the domains. We can organize university hackathons, either for the famous reproducibility hackathons or security hackathons was another idea that is spinning around to improve security of university infrastructure. What we also believe, if we have these institutions, they will, on the one end, they will bring up the young generation of RSEs, but software engineering is a fast-moving target. We believe that they should also be places for lifelong learning of graduated RSEs, so that they at the one end, the RSEs know where they can learn new skills, and on the other end, the employers, so RSE groups at some departments, know where they can send their RSEs to pick up new skills. And also, they will be most likely be local points of contacts for into transnational networks, either into the wider RSE community or into the wider university network. Because we believe that research software engineers, they are not at the end when they have graduated, they should know and get the feeling that they have a wide and strong network where they can fall back into a community that supports them and where they can find help if they encounter issues. As already alluded to, we also are currently working on an RSE master's program, separate project, in contrast to the other two papers, which really digs into the details of how much ECTS points to assign to a particular course. So this is a software project not a software project. This is a project driven by Philipp Thiele. And we designed that currently as a 4-semester master. And the master should be done in conjunction with a domain science, so that people are actually performing research in some domain. In this 4-semester course, we have selected courses according to the 3 pillars from the competency papers, definitely from existing courses in computer science. So, for example, software engineering skills, 2 different programming languages should be offered to people where possible. Also, team skill, communication skill courses, so project management, software project management, but also adult education can be put into here, that people become more effective teachers for their colleagues. It will include a large number of practicals where people actually develop software and contribute to software projects. Hopefully, also to actually working science project at the university. And what we also want to motivate people to while they come from a domain background with a domain bachelor, they should do some research, some software development research project outside of their home domain, so that they really learn how to interact effectively with different domains of science. While at the same time being offered the possibility to continue some courses in the scientific domain. So that if you have to have a bachelor's background in physics, you have to do a project outside of this domain. You do a project together with a biologist, but at the same time you can learn the course. You can take the courses on high energy physics, so that you can contribute to a software project doing quantum lattice something. Forgot the abbreviation. If we have these masters, so maybe you want to contribute maybe you want to find resources where you can design your own courses, or you want to learn how to which courses already are out there. This has been this project, the Learn and Teach project, led by Gerasimos Choudakis, has been comes from the literature survey that we basically initially did, what other projects are already out there, and they are numerous. And we thought, well, maybe we should not fix them into a paper, but it makes more sense to have put them into a software project that is hosted on GitHub, where you contribute your own resources, your own links and so on. We curate them a bit, and then we offer them to the wider RSE community. So have a look over there. The Learn and Teach project is happy to take your contributions on new RSE resources, open pull requests, and we see where to place them. So to come a bit closer to the end. So the last paper that or the last project, then of course, if we have institutions formulated, we need to ask ourselves how to adapt that to Germany. What are the required policy changes? The thing that we would likely encounter, how to force more interoperability already in education. It's that multiple faculties are working together to offer a master's program where people can very much mix and match each other. Another thing, how to ensure that graduates can access funding sources in their daily work. This is basically on the requirement. Some funding sources require a PhD, some don't. Here we have to ask where do we want that? How easy will it become to come up with something like a PhD equivalent? What does that mean? Would there be maybe there's a way to certify these things? These are topics that we want to work on in the final paper, the call to action on policy changes in Germany. And assuming we have done all that, what comes beyond that? I mean, these are opinion papers that we're currently working on, but then, well, it comes to the implementation. So we actually need to form organizations and respective study programs. So for the study programs, I know of programs in Potsdam and Aachen, where people are working on that. Then with the help of the Klaus Tschirrer Stiftung, the master's program that we are currently working on, we need to form networks of educations. And well, at some point in time in the future, there will be a day when we actually have our first RSE graduates that have decided for their own that they want to pursue this as a career in their future. And hopefully we were able to motivate them that this is a career path worth pursuing, that they find something, find a meaningful life in there. So who are we actually now, the teachingRSE project? And it is a pleasure basically to thank all my collaborators. And yeah, we are numerous already right now that have contributed over the last 1.5 years to the paper, to the project, with their ideas, their time, and their work. I thank each and every one of them. So if you need to know more and you know one of these guys over here, maybe ask them. They can give you more details and how to contribute. And if you want to join our project, so we are a special interest group of the DRSE Society by now, and also in the Fachgruppe Research Software Engineering of the Gesellschaft für Informatik. We have a GitHub organization. The link is over here. Over there you find the meeting notes and details. Currently, we meet every Monday afternoon to work on our papers. You have a mailing list that you can subscribe to get notified of current events. And yeah, currently we are planning for a workshop at the DRSE 25 in person, where you can meet us and contribute with your ideas. Yeah, let's see if we actually find at the DRSE 25 that space and time to perform this workshop. But nevertheless, you have the online opportunities for joining. And with that, I'd like to thank you for your attention, your time, and I'm open for your question.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below and see you next time.